Hello everyone, this is Vahe coming to you with the introductory video for experiment number 2x. This short video will tell you about the particulars of this experiment, but it follows pretty much like experiment 1. By the time you get the notice for this video, you will have information in the lab section of Blackboard, just like before with the experiment 2x the report template, which will be exp2x.docx. It's a Word file, okay? And then there will be some already written MATLAB programs, prog1.m through prog7.m. You're seeing that on the screen right now. So this is what you will see, and all those files are ready for you to work with. In addition to that, you'll have a link to this video, which is right now being produced. That's why you don't see the link there. So you'll have the documents, the programs, and then the link to this video. So you watch the video before, and then it'll tell you about what to expect through the video, and you'll just go through it basically. The only thing in the video that you'll notice is that I will be referring to a PDF document of the report template, whereas you're getting actually a fillable Word document. But the contents of the lab reports that are shown in the video are exactly the same. It's just that you're getting actually a more recent and a fillable version of that document where you go in and just fill in the blanks just like it is for experiment 1, okay? But you might see that the document that's being used in the video is actually a PDF document, so don't really worry about that. The contents are exactly the same. So before you begin the video, before you begin the experiment, what you should probably do is, you download all these files to your computer, like the document docx file that has the experiment 2 template, for example, in each of the programs, and for the purposes of this illustration that I'm going to be showing you in a few minutes, just like what I've done is I've right click on the program name, save link as, or however you want to do it in your browser. And I chose my desktop to illustrate this. So just go to your desktop and save each of these 7 files. I've already done that, and they're sitting right here actually. So here are the 7 files that are already written for you. You don't have to rewrite them. This is what you're going to start with to do the lab report. And this is what the lab report template is referring to. Okay, so once you once I have done this, I can just proceed with launching MATLAB as usual. And as I said before, you can launch it, the MATLAB, and use MATLAB 2 different ways. One way is if you've installed it on your computer, or another way is by using the remote desktop. They're both fine, but one might work a lot more convenient for you. Okay, and sometimes when you're having issues on your computer, remote desktop is always a good option. It'll work just fine. I know many of the students used it, and they actually really like it. So because they don't have to really install anything, and all the programs are there, so that will be a fine way of doing it. Okay. So now that we have everything set, let's just jump in and launch MATLAB, and we'll go from there. Okay, let me launch MATLAB, and here it is, right? So when you start MATLAB, as I said last week, what you will see is, you will see these, the command window and some other windows that shows the variables, and then this particular window here called the current folder, which shows the contents of the directory that's shown right above here. So like for my particular computer here, it's the C drive folder users, Vahe, documents, MATLAB. So whatever computer you have, that's gonna be something else. Or if you want, you can point it to where you want it to point to. But for now, I'll just leave it as is. But for simplicity, you should take all these files and simply move them into this folder. So you can either go to this folder and go with your file explorer, just go there and put these folders in there, Or if you have MATLAB open like this, simply select all these files and just drag them into the folder, and now you got them. So now these folders, the folder now contains these 7 files, and it will be very easy to access them simply by double-clicking them. Or if you want to run them as they are, you can just type in their names without the .n. So you want to run program 1, you can just type in prog1 or program 2, etc. So there's different ways of doing it. I'll show it another way in a second. But this is the mechanical portion of it. Just have these files and download them. Now you're ready to proceed with the work. And if you go to the procedure, let's go to the procedure for a second. Okay. Let's start with the first one. It says, okay, procedure. It'll remind you to copy the MATLAB folders into the current folder, as I have just done before you start the document. So here's the contents of program 1, prog1.m. So if you want to, like I said, you can just type in prog1 and see the results. But a better way to see this, the input file over again, is to simply go to this list, right? The name of the program. Just double click it, and when you double click it, MATLAB will launch its file editor. So now you're seeing the contents of that file, okay, in MATLAB's file editor. And so once you have this open, if you want to run it, you can just click this, the green arrow, and you can actually run this program through. The nice thing about this is that MATLAB does syntax highlighting, so you can see, for example, that green things are all comments. They are not written; they're just there to help you, with identify things or basically document things. And then you also have other colors for different parts of this program, like for example, a title and the DISP, the display command. The strings that are in those, for example, are in blue. Okay, grid on, for example, the on and off. Actually, they'll be in blue. So there's some things that are highlighted that way. Helps you out when you're typing it. So pretty much every single program here can be run exactly this way, right? So you want to run this, you can just click the run button, and MATLAB will run it. In this case, you get actually this this graph, and then it says press to continue, and it'll just actually MATLAB will sit there until you go to the screen and press enter, which I'm going to do now. And once you've done that, you see the plot that came up. You see the individual variables that are in the workspace, and once you've done this, you're ready to answer the questions, right? So what does line 6 do? Explain what line 6 does, etc., right? So, what I just did is the starting point for each of these 6, or sorry, each of the 7 programs that are in there. Okay. So this is just the way it goes, and then if you're not sure about something, you use the help command. Obviously, help command is in fact sometimes it says like for example this line here, use help for pause. So you could say help pause and figure out what that function does, right? So they're all pretty straightforward. In program 2, we use imaginary numbers. I think most of you probably had imaginary numbers in trigonometry probably, but you don't really have to know too much about them. It's just that imaginary numbers both have real parts and imaginary parts. So when you have a real and imaginary part, that number is called a complex number. Complex number has real and imaginary. The real part is by itself, and the imaginary part is the one that's multiplied by I, and I is the square root of -1. We'll do a lot more on this, but for now, I think you can just go and find or just determine what these things do. I think you'll find it pretty straightforward. what you'll see is that when you add complex numbers, you add the real parts and you add the imaginary parts separately. So it's like adding a vector, x and y coordinates. So I think this should be actually straightforward if you just follow and just answer the questions. Basically, it's pretty straightforward. This is a way for you to find out about some of these things. So I'm not gonna be telling you every single thing, but I think a lot of you already know how this goes. Okay, so just go through and follow the procedure, and for each of the programs, simply double click, like for program 2, double click, and this is tabbed, so the second tab comes up when you're here. Run the program, and you get all of the variables, and then answer the questions. And what you'll see is that in for example program 2, you refer to line 30. That line 30 refers to the highlighted or commented line 30 over there. You won't see these numbers being anywhere close to the numbers that are shown. Okay, this is just to differentiate between all the lines in the code for all 7 programs. So I think this should be pretty straightforward. And whenever you're asked to make some adjustments or add statements, you can simply go into the program here, press enter a line, and rerun the program and see what changed, basically. Okay, so I hope you find this to be pretty straightforward, as it was probably last week as well. So we're just getting started with our stuff, and you're getting some taste of MATLAB. But again, EC 115 is obviously not a course on MATLAB programming. MATLAB programming that we could dedicate 2 separate semester courses to MATLAB programming. All right, so that gives you an idea. Now the other thing is that even though these are already built-in programs, and this is what we call scripts, basically. So it's a series of commands. If you click on another program, for example, it's just a series of commands that have been written back to back to back. And instead of running these over and over again, you save them to a file and you run it when you want to, and then you go back and adjust it, and etc. Right? So these are just scripts, a series of MATLAB commands that are put back to back. And when you run the program, they're executed in order, back to back. So that's what that is. Now, it's also another way that MATLAB is used is you can make your own functions. And so functions are a little bit different because they're more interactive. So you have to give some more information. If you just run it, nothing really happens. You have to give it some inputs. So, and of course, you've already interacted with built-in MATLAB function. For example, if we look at this program here, sine of an angle is a built-in MATLAB function. So you say sine, and in the parentheses you put some number, it returns the sine of an angle, right? It takes the angle to be in radians, right? But that's a built-in MATLAB function. Cosine, sine, tangent, the exponential function, natural logarithm, these are all built-in functions. But you can make your own functions. So I wanted to just illustrate, just give you a hint, or just give you a taste of what kind of functions you could do or how they look like. So let me just move this function to the space here. It's called par2.m. So let me just move this here to my working directory. Okay. And let's just open it up to see what that is. Okay, so if you open it up, what it is actually is a function called par2. It has 2 inputs, okay, or it has 2 what we called arguments. So you give it 2 resistors actually, or 2 numbers, R1 and R2, and the resulting equivalent resistance is the output, right? So, and the way you run it, and you say par2, and then you put 2 numbers separated by a comma, and it'll give you a parallel combination. So now, this this function called par2 is not a part of MATLAB. It doesn't come with MATLAB. I just made it up basically. I cooked it up. So the way you write a new function is kind of like what I'm showing you here. Okay, so you write the word function, and you in square brackets you put the resulting number, and then you put equal signs, and then you write how the function will look like to the user, right? Part 2, parallel combination of two resistors, and then the arguments R1, R2. And below I'm showing you how I calculate R equivalent from given R1 and R2, and then end. So now, if I put part 2 in this directory, okay, as I have done, I can use this as a custom function. And I don't know if you can notice, but in the folder in front of part 2, the symbol icon for part 2 is different. It actually has the letter FX on it. So MATLAB realizes that this is actually a function. So anyway, I can now use the function part 2. But again, remember, you cannot access the part 2 function unless it's appearing in your current folder. So it's important to know where your current folder is and what to put there. Or make sure you put things there before start typing in commands that I'm going to type in. So let's try it. Okay, let's say part 2. Okay, let's do 10 comma 10, right? So 10 parallel 10, product over sum, 100 over 20, 5 ohms, right? So there you go. Okay, so you can type in any number that you wish. We can say 3 and 6, for example. I know that it's going to be 2, right? 3 parallel 6 is going to be 2. Okay, because it's going to be 18 nines. But I can put anything. Also, if I wanted to, how would I do parallel combination of 3 resistors? Right? Let's say I had R1, R2, R3, or in parallel. How would I do that? So let me take a test case, right? So if I have 3 resistors that are all 10 ohms, right? So 10 parallel 10 parallel 10. If I do my equivalent circuit calculation, it's going to be 1 over R1 plus 1 over R2 plus 1 over R3. That's going to equal to 1 over R equivalent. Also, we know a shortcut, right? If all resistors are equal, right? If I take a parallel combination of any number of resistors and they're all in parallel, the parallel combination is simply the common value, right, divided by the number of resistors. So if I have 3 resistors in parallel, they're all 10 ohms, my equivalent resistance is 10 thirds. If I had 4 10 ohm resistors in parallel, it'll be 10 fourths, 2.5. If I have 5 10 resistors in parallel, it'll be 10 over 2, right? 10 over 5, which is 2 ohms, right? So there's some calculations that I can do by hand, just to double check, right? So I can make a new function called part 3, and I can kind of figure that out. But there's actually a way to do what I just said by using part 2. So let's say, as I said, I have 3 10 ohm resistors in parallel. I can find the parallel combination this way. I can say parallel combination of 2 resistors. The first resistor is 10, and the second resistor is not 10, but it's the parallel combination of 10 parallel 10. So you can put the parallel function inside this parallel function, right? So what this will do is, actually, it will compute this first. And when it computes that, okay, it's going to do 10 parallel 10, it's going to be 5. And it's going to do 10 parallel 5, right? So the outside is going to do 10 parallel 5, and hopefully this thing should report 10 thirds. And it does, right? So you can keep nesting these things when you make a function. It's very, very powerful. But anyway, that's just a simple way to encapsulate that parallel function, because if it's something that you're using over and over and over again, instead of writing the function over and over, instead of writing 1 over R, 1 over R2 over and over again, you make a function, one line, it takes care of it. Okay? So I hope that gives you a feel for what you can do using something that we've seen in class, which is the parallel operation, right? That's a very, very common operation, and we know how that goes. Okay, so let me show you something else. And in this case, I'm going to show you what's called a voltage divider program. Okay, and it's a little bit interactive. Not very interactive, it's actually very straightforward. Let's double click and take a look and see what's in there. And I'll also clear this up. Now, this is going to look like there's a lot of things going on, but it's actually very simple. So this is basically a way for us to automate voltage division, okay? So this just assumes we have the standard voltage division set up, right? We have Vs and we have two series resistor, R1 and R2, right? In fact, the comment up here just kind of tells you that, right? So what this program does is it'll display voltage division, okay? When I run it, you'll see it in a second. And then it'll ask you to enter in the source value, Vs, and in the R1 and R2 values. And by using the voltage divider formulas that are shown over here, okay, what it's going to do is it's going to calculate those V1, V2 values numerically, and then by using a little bit of text and the actual value, right, it's going to print out voltage across R1 is V1 equal to some numerical value volts, right? So it's basically going to just print these out for you, just a little interactive thing to show you what you can do. So this V1 text, V2 text are textual, right? They're actually strings, they're not numerical values, but it does contain a number in there from our calculation. But it just kind of gives you what you can do, and you can just take this example and kind of work it, change it, manipulate it, and you know, you'll be able to basically you know, cook up your own results like this. We'll actually do a little more of this later on. I'm just showing this as an example. You will not have to do all these things for experiment 2, obviously. I'm just kind of show you the kind of things you can do, more interactive, right? So when you want to run this program, you can hit run over here, right? Okay, this arrow, green arrow, or you can type in the name of the M file. In this case, volt underscore div. If I can type, it'll be nice. Okay. So when I press enter, okay, it says voltage division. Enter Vs. I don't know. Let's say we entered 12 volts. Okay. R1 is 3 ohms. R2 is 6 ohms. Press enter. And it says voltage across V1 is 4. Voltage across R2 is V2 equals 8 volts. So is that true? I don't know. Try it by hand and see if it works. Then try other numbers, right? For example. But this would just be a little, you know, if you wanted to show someone some application of what you learned, here it is, right? I mean, maybe you can add in statements that calculates participation in R1 and R2, or how much power is generated by the 12 volts, right? Things like that. You could add all these things on, and you can make it more and more and more, you know, complicated, right? Maybe not complicated, but you know, more detailed. Let's put it that way. So that's just what I wanted to show you. These last two things that I showed, the parallel combination and this interactive program, I mean, I'm just showing you those because you know, we do talk about functions and scripts and things like that, but you know, we're not making you do that now. We're going to have another MATLAB experiment. I believe it's experiment 6 or 7 that you have to do some of these things. But even then, you know, we'll give you examples and it'll be well documented. So I hope you find this useful. I think the experimental procedure is pretty straightforward. It's more like learning by doing kind of an activity rather than you know everything and you're just going through the motions. You're not expected to know everything. But by doing it and by asking the questions, you find out about it. That's the whole purpose of these experiments, is to learn by doing. So if you look at the procedure right now and you have doubts or questions and you're not sure you understand every single line of code in there, don't worry. That'll be resolved as you do it. And of course, in the lab, please ask questions. Our TAs, our graduate TAs, and also our undergraduate TAs they're very knowledgeable. They've done this before. They've gone through it. They're in a very good position to answer your questions. So with that, I'm gonna say goodbye for now, and I hope to see you very soon. Bye bye.